Okay, so I have to add another form to our list that I didn't realize you'd learned yet. So I've got these guys. We know this, we know e to the x, and you also know that the integral of 1 over x is the ln of the absolute value of x. So this is another form that we can get if I can make the denominator a u. Sometimes that's helpful. So that's what I'm going to do here. I'm aiming to get this. And then of course I should be writing the plus c's, but I get a little lazy. So now you're going to make your u equal to the bottom. So your derivative 4t minus 3 dt. And you notice you don't quite have that on the top, but if you rewrote the top and you factored out a 2, there's your 4t minus 3. He's hiding just a little bit. So now when you go to rewrite, this entire 4t minus 3 dt comes out and gets replaced by a u. And so your integral in terms of u will be 2 du over, and then the whole bottom was what we rigged to be u. So you can pull the 2 out if you'd like to make it look more familiar. And then there's what you were going for. Now again, because we have limits, if you choose to ignore the limits for a while, some teachers allow you to just kind of do star, double star sort of deal. And you could plug back, oops, so there's no plus c because we're limits. So let's change our limits just to get in that habit. So when the x is 3, the u would be 3 squared is 9 times 2 is 18 minus 9 minus 2, so that should be 7. So my new lower limit is a 7. And then when x is 4, 4 squared, 16, 32 minus 12 minus 2, so that's 18, I guess. That's the idea. So then you can do from 7 to 18. So now you're going to evaluate this from 7 to 18. So you'll have 2 times the ln of 18 minus the ln of 7. And that's fine. The back of the book might decide to use the properties of logs to make that 2 times the ln of 18 divided by 7. That's kind of cute. But either way works for me.